times cosecant squared x equal to 1. So let's start with the left hand side. So cosecant squared x minus cosine squared x times cosecant squared x. Let's recall the identity of reciprocal identity. So the reciprocal of cosecant is 1 over sine x. And the reciprocal for cosecant squared x is cosecant squared x is equal to 1 over sine squared x. So having the knowledge of reciprocal identity can help you in proving this equation. So let's substitute this reciprocal identity to this equation. Let's rewrite the equation to 1 over sine squared x minus cosine squared x times 1 over sine squared x. After substituting the reciprocal identity of this expression, we need to factor out 1 over sine squared x times 1 minus cosine squared x. You just need to get the manual factor of this expression. Next, we need to apply another identity, which is the Pythagorean identity. So let's recall Pythagorean identity. So in Pythagorean identity, sine squared x plus cosine squared x is equal to 1. Therefore, let's manipulate this equation. It will be 1 minus cosine squared x equals sine squared x. So from this equation, manipulated from the Pythagorean identity, so this expression is equal to sine squared x. So we need to substitute 1 minus cosine squared x with sine squared x. So the last equation katong factor out is this one. So we know that this expression is equal to sine squared x by using the Pythagorean identity. So we just need to substitute, so it will be sine squared x times sine squared x. So it will be sine squared x over sine squared x equal to 1. Thus, cosecant squared x minus cosine squared x times cosecant squared x is equal to 1.
We are given to prove the identity of 1 minus 2 sine squared x equals 2 cosine squared x minus 1. So we start by expressing both sides in terms of sine or cosine using the Pythagorean identity. So as we recall, the sine squared x plus cosine squared x equals 1, which can help us to rewrite the term in the equation. So to find the value of sine squared x, pwede na to ibalhin si cosine squared x sa right hand side. So sine squared x equals 1 minus cosine squared x. So now we can substitute sine squared x equals 1 minus cosine squared x from the original equation. So kaning original equation atong substitute si sine squared x. So mahimo na siyang 1 minus 2 1 minus cosine squared x equals 2 cosine squared x minus 1. So, i-distribute nato si negative 2, 1, negative 2 times 1, negative 2, negative 2 times negative cosine squared x, mahimong positive 2 cosine squared x equals 2 cosine squared x minus 1. So now we can simplify 1 minus 2, negative 1, plus 2 cosine squared x equals 2 cosine squared x minus 1. So, ato nang i-arrange para mas makita if same ba jud both side. Negative 1 plus 2 cosine squared x equals negative 1 plus 2 cosine squared x. As you can see, both sides are now identical. We have proven the identity. These steps involve rewriting the left-hand side using the Pythagorean identity and simplifying, leading to the same expression of the right-hand side. Therefore, the equation 1 minus 2 sine squared x equals 2 cosine squared x minus 1 is a valid trigonometric identity.
Prove that sin x plus tan x all over 1 plus cosine x is equal to tan x. Let's recall what we know. Let's review the trigonometric identities that equals to tan x. First, we have tan x is equal to sin x over cosine x, and tan x is equal to 1 over the cotangent of x. However, since there are no cotangents in a given equation, let's start with tan x is equal to sin x over cosine x. Let's substitute the tan x on the left-hand side with sin x over cosine x. After doing that, we have sin x plus sin x over cosine x all over 1 plus cosine of x. After that, let's go ahead and simplify the numerator. And that would be, first let's identify a common denominator, which would be cosine x, and simply multiply. After simplifying the numerator, notice that after unifying the fractions, notice that the numerator can be simplified further following the distributive property. Let's go back to the original equation with the simplified numerator. Sin x times the quantity of cosine x plus 1 all over cosine x divided by 1 plus cosine x is equal to tangent of x. Then let's simplify the left-hand side of the equation. Remember, when dividing fractions, simply copy the dividend and multiply it with the reciprocal of the divisor. So we have sin x times the quantity of cosine x plus 1 divided by cosine x times 1 over 1 plus cosine of x. Then simplify, which is just multiply 2. Then we have sin x times the cosine of x plus 1 all over cosine of x times 1 plus the cosine of x is equal to tan x. Since the cosine of x plus 1 and 1 plus the cosine of x are the same, they cancel each other, leaving what is basically the ratio identity of tangent. Since we know that sin x over cosine x is equal to tangent of x, we can say that the tan x is equal to tan x, which is true. And then we have proven the equation to be true.
Today we're diving into the world of trigonometry, and we're going to tackle a classic identity proof. Get ready to see how seemingly different expressions can be shown to be equal. Our mission is to prove that this equation is true. 1 plus cosine x over 1 minus cosine x is equal to the quantity of cosecant x plus cotangent x squared. Let's start by taking apart the right side of the equation. Remember, squaring something means multiplying it by itself. The quantity of cosecant x plus cotangent x squared equals the quantity of cosecant x plus cotangent x multiplied by cosecant x plus cotangent x equals cosecant squared x plus 2 cosecant x cotangent x plus cotangent squared x. Next, we rewrite all the trigonometric functions in terms of sine and cosine. This makes things easier to work with. Cosecant x equals 1 over sine x. Cotangent x equals cosine x over sine x. Let's substitute this into our expanded expression. The quantity of 1 over sine squared x plus 2 times the quantity of 1 over sine x times cosine x over sine x plus the quantity of cosine squared x over sine squared x. Now, let's clean up the expression by combining the terms with a common denominator. Let the denominator be sine squared x, and in the numerator, copy 1 plus expand 2 times 1, 2 times cosine x equals 2 cosine x plus cosine squared x. Now we factor the numerator because, as you notice, the numerator is a perfect square trinomial. Now we have the quantity of 1 plus cosine x squared over sine squared x. We can use the Pythagorean identity sine squared x plus cosine squared x equals 1 to rewrite the denominator. Now we have an expression, the quantity of 1 plus cosine x squared over 1 minus cosine squared x. Now we can factor the bottom. As you notice, the denominator is a difference of square, which we can factor as the quantity of 1 plus cosine x times the quantity of 1 minus cosine x. Now we have an expression of the quantity of 1 plus cosine x squared over the quantity of 1 plus cosine x times the quantity of 1 minus cosine x. Now we can cancel the common factor of 1 plus cosine x in the numerator and denominator. And now we are given the expression of 1 plus cosine x over 1 minus cosine x. Now we have successfully transformed the right side of the equation into the left side. This proves that the original identity is true, which is 1 plus cosine x over 1 minus cosine x is equal to the quantity of cosecant x plus cotangent x squared.
Letter E. Prove that sine x over 1 plus cosine x is equal to 1 minus cosine x over sine x. First, let's look closely at the equation and think about what we can do. First thing we notice is that the equation is a rational equation. Thus, we can try rationalizing the denominator in the left-hand side of the equation. We simply take the conjugate of the denominator and multiply it to the numerator and the denominator. This does not change the equation since we are basically multiplying by 1. Then we simplify. Notice that the denominator in the left-hand side is simply a difference of 2 squares. Recall, a squared minus b squared is equal to a minus b times a plus b. Thus, we can simplify it further. Still, focus on the denominator on the left-hand side. Doesn't it look familiar? Let's recall the Pythagorean identities. Cosine squared x plus sine squared x is equal to 1. If we transpose to cosine x, we get sine squared x is equal to 1 minus cosine squared x. Now it looks exactly like our denominator. Thus, we can substitute 1 minus cosine squared x with sine squared x. Notice that we can cancel a common factor, which is sine x. And that gives us a final answer. 1 minus cosine x over sine x is equal to 1 minus cosine x over sine x, which is true.